Hello everyone, today I will be talking about the Feynman diagram created by the renowned physicist Richard Feynman. To begin, I will be stating the definition of the Feynman diagram. A Feynman diagram is a visual representation that shows what happens when elementary particles collide with one another on a subatomic level. Elementary particles include all subatomic particles. And before we get into how the diagram actually works, let's learn a bit about how it came to be. In the early 20th century, the theory of quantum electrodynamics was a problem that physicists had been trying to crack for ages. This theory tried to explain how light interacts with matter on a subatomic level. However, the problem was light interacts differently when put under different circumstances. For example, light is refracted through an oil or a prism medium. However, it is reflected through a glass medium. In each scenario, light is interacting with matter differently on a subatomic level. This is because of the way electrons exchange photons. Photons are essentially this giant ball of energy created by the passing of electromagnetic force, which is what light is. Light is an electromagnetic force. The problem is electrons and photons are unpredictable, so these physicists need to figure out a way to predict how electrons and protons interact and behave when put under different circumstances, because that's how they will be able to see how light interacts with matter on such a small scale. But this is a difficult question to answer because electrons and protons behave however which way they want, meaning there's an infinite amount of answers for this question. This is when Feynman creates the Feynman diagram. His diagram showed that two electrons moving through space with one electron emitting a photon that is absorbed by the other electron, which is called a positron, and then both of these electrons move off that form quarks. But this line in the middle is the photon that is emitting light. This entire scenario is plotted against time, so the interaction between electrons could happen at any time. He then adds equations that were used to describe the interaction of these particles to the diagram. By adding and multiplying the amplitudes derived from these equations that were expressed by the diagram, one can calculate the total probability of these particles to bounce off one another in any particular direction. Suddenly, you had an answer as to how electrons and photons behave, giving you an answer for how light would interact with matter under any given circumstance. The Feynman diagram is very important to the world of quantum mechanics as it's essentially a way to predict how light will interact in any given situation, which allows for a better understanding of technologies related to light and how we as humans can manipulate light to our advantage. These diagrams are used to understand how light interacts with matter in almost every area of quantum physics and has allowed physicists to solve many problems that have led to useful technologies such as quantum computers and nanotechnology. Richard Feynman was awarded the Nobel Prize in Physics in 1965 for his creation of the Feynman diagrams, and his legacy is forever embedded in these diagrams.